Trail and ultra runners, what is going on? Welcome to another episode of the Koopcast. As always, I am your humble host, Coach Jason Koop, and this episode of the podcast is all about nutrition strategies that you can potentially use to help mitigate exercise-induced muscle damage. I don't need to tell you guys that we go through a lot of skeletal muscle damage throughout the course of racing and training, and there have been several purported mechanisms for how we can actually reduce and cope with this better. So welcome onto the podcast an expert in this area, and d.j.owens, who is an associate professor in cellular and molecular exercise physiology at Liverpool John Moores University in the UK. His research really sits at the crossroads between nutrition, muscle metabolism, and muscle adaptation. And more importantly, Dan is one of those guests of this particular podcast that I extremely enjoy because he has an academic interest as well as being a practitioner where he is advising athletes across a number of different sports. The two supplements in particular that we focused on throughout the course of this podcast are two supplements that will be readily identifiable to you because they are things that we see proliferated across the podcast space and in the lay literature as potentially having some type of ergogenic effect, and that is omega-3s and vitamin D. Those should be readily identifiable to you guys if you've been paying any attention to the space recently. So we decided to cut through a lot of the clutter and determine what does the research actually say about these two particular supplements as it relates to exercise-induced muscle damage. All right, folks, with that as a backdrop, I am getting right out of the way. Here is my conversation with d.j.owens all about nutrition strategies to help avoid and mitigate exercise-induced muscle damage.
All right, let's do it, man. Let's get into it. Like I was saying off air, I appreciate you coming onto the podcast today. For whatever reason, my podcast over the past several weeks has had a supplement heavy theme to it, and I don't know what to attribute that to other than a sign of the times and us being influenced into supplements, this, that, or the other. And that'll certainly be at least a part of the podcast today. But before we get into it too much, we're going to talk about exercise-induced muscle damage and what we can do about it. Just so the listeners can get to know you a little bit better, Dan, can you briefly describe what you do professionally and how you got into this line of research and interest?
Yeah, absolutely. So I work at Liverpool John Moores University in the UK. I'm an associate professor there, but that essentially means I just get to do interesting research. So most of my research is around nutrition, muscle metabolism, exercise adaptation. So that takes on a lot of different themes, really. We're just interested in how can we maximize the response to training? How can we maximize competition and competitive performance? And how do we maximize recovery as well? So we've been in a number of different areas. My specific interest in what we're going to talk about today with exercise-induced muscle damage probably came from my PhD, which was a while ago now. I'm not going to say how long ago because it'll give away how long it's been. In that PhD, I was interested in vitamin D and its role or potential role in muscle damage, repair, and remodeling. And so even though it wasn't the central theme, the theme was vitamin D, I got really interested in muscle damage. I learned a lot about it, and it stayed as a theme of my research for a while. I'd say in parallel to my academic career, I've also been working with athletes for a long time, professional athletes for probably the past 8 years or so. And I also coach athletes at my local club, which is North Endurance. So I thought I'd put my t-shirt on for them today. So,
Perfect.
So I've really I've got a lens on it for myself of, what's going on in the real world and how do we study that in the lab. So that's a theme for what we do in our work, is practically driven, but we try and get to the sort of mechanistic underpinning of it. So yeah, I just go with what's interesting and what's pertinent to the athlete and how we can help them.
Well, and so you touched on it a little bit earlier. We're going to discuss exercise-induced muscle damage today. And I think it's ultra running in particular is a really great cohort to study this. And in fact, as you're aware of, a lot of the exercise-induced muscle damage studies are done with runners in a downhill condition, very prototypical setup. You put people on a treadmill, you have them run hard downhill for 20 minutes or so, and that's enough. That's enough of an exercise bout in a specific enough condition to induce enough muscle damage to study some sort of phenomenon, either an intervention that you're trying or some sort of training protocol that you try beforehand, and you can kind of test them before and afterwards. And most ultra runners are familiar with the soreness component of this, right? They finish a big, long ultra marathon, and in the day afterwards, the 2, 3, 4 days following the race, they just have a lot of soreness, particularly in their quads, which is slightly different than the actual damage that is occurring. So since we're gonna spend a lot of time talking about muscle damage itself, why don't you kind of set the table on that with what runners might be familiar with in terms of soreness, or DOMS, as we would refer to it in clinically or from a coaching perspective, and then what muscle damage actually is, and how we think that actually impairs performance.
Yeah, so it's a great thing to sort of clear up early on, because it's kind of a complex area, mainly because exercise-induced muscle damage itself doesn't really have an operational definition. So you can't really just pin it to one definition of this is what EIMD is, but rather it's associated with a set of symptoms or signs. So DOMS is one of them. That's the one that most people will be familiar with, that feeling of pain in the affected limbs. But there are also other signs as well. So you might have some swelling of the limb. It might not be noticeable, but if we measured it with even a tape measure, you might see some swelling. You would also have a sort of a changed sense of awareness of limb positioning, so proprioception can be affected. But the big one is that there's a decrease in muscle function. So there's a big drop in muscle force with muscle damage. And that is the best marker of how much damage you actually have, outside of looking down the microscope at the actual damage itself. So with regards to pain and the DOMS that athletes might feel, what's a little bit misleading about it is that the degree of pain that you feel is very subjective, and it doesn't correlate that well with the amount of damage that you have. So the sorer you are doesn't mean there's more damage per se. When we sort of look at this in I suppose, a little bit more finer detail, and if we were to have the sort of specialized equipment that we might have in the lab here, obviously not available to your everyday athlete, but we can do some studies and look at what's actually going on. And muscle damage really probably lies on a spectrum from mild damage up to severe damage. We typically would say sort of mild muscle damage would be a loss of function of anywhere between like 15 or 20%. And we just measure function by the maximal force generating capacity of the muscle. So it can be done in a number of different ways, but the ability to produce force. The other end of the spectrum would be severe damage, where you might have 50+% loss of force, which is like really significant. But the underlying differences here is that in severe damage, the muscle degenerates and then has to regenerate. In mild damage, it can be repaired quite locally. And so where you are on that spectrum really depends on what the type of exercise is. So it's really driven by the cause and the underlying exercise stimulus. But across that sort of spectrum, you're going to get pain. So it's not a reliable indicator of how damaged the muscle actually is.
I appreciate that definition, and kind of the forthcoming of, we don't really have a good operational definition of this. A lot of athletes will, and coaches who are listening to this podcast, will also be familiar with some of the like surrogate biomarkers that have been used in the literature to try to describe some of the phenomenon that you just described here, pain, swelling, and things like that. Most notably, things like creatine kinase and interleukin 6. And I'm wondering if you can if you can describe some of those biomarkers a little bit better so that when people come across it in the research, they kind of understand from a physiological perspective what's actually going on when some of those things are elevated or depressed or clear or whatever is actually happening in the particular paper.
Yeah, absolutely. No problem at all. So, yeah, with the research, like all research, we kind of look for a number of different signs to indicate that something has happened. And for a long time, people have looked at things like creatine kinase, other things that might leak out of the muscle, so to speak, when it's damaged. But creatine kinase has been, I suppose, has been one of the key markers of muscle damage. The problem with creatine kinase is a little bit like pain. It can tell you that damage has happened, but it can't tell you the degree of the damage. So in some cases, after, let's say, an ultra event, you might see creatine kinase 1,000-fold increased to what it is at baseline,
Yeah.
but it can come down pretty quickly as well. So it's not really clear what it's an indication of, other than there's been a pretty big insult on the muscle. So it's not a great indicator of the degree of damage, but essentially it's thought to come from the muscle, and be an indicator that the muscle fiber membrane is somehow disrupted, and therefore it's got out, and it's an indicator that there's been some physical damage. The other thing that you mentioned, like interleukin 6 or IL-6, this is an inflammatory cytokine, and there's a lot of inflammatory cytokines. Essentially, their job is a way of signaling to the immune system to mount a response to something. Now, in the case of muscle damage, this is, I suppose, quite a debated area, in that it's not so clear what the role of this is under, let's say, mild muscle damage or severe. So in severe muscle damage, it's quite clear we need an immune response to come in, get rid of the broken down muscle tissue, clear it out so that we can rebuild in that space. That's simply what the immune system is doing there. And it's very tightly regulated. It goes from a pro-inflammatory state to an anti-inflammatory state on its own. So it's doing this without any intervention. But even in milder cases of muscle damage, you still might see an increase in some of these inflammatory cytokines. And as we might get to a bit later, I'm not sure these things are something that we should see as being a real negative. There's a number of reasons to think that these are important signals for both recovery, but maybe even also for adaptation as well. So I'd say, yeah, the creatine kinase and so on are things that probably leak out the muscle. The inflammatory cytokines are things being produced by a number of different cells to kind of signal an immune response.
I'm going to play off of that a little bit. This whole need a response concept that you just went over, because a lot of times when we talk about physiological or some sort of insult to the system, our vantage point is that is inherently negative, and we need to do whatever we can to try to mitigate it, whether that's oxidative stress or damage to the muscle or anything in that kind of realm. And inevitably what happens is there's any number of different strategies to do whatever you can to actually mitigate it. However, when I look at this as a coach, and you look at this as a coach as well, we realize that we need a certain amount of stress in order to trigger the adaptive response. So not all of these insults are inherently all negative. Sometimes the magnitude of them or the duration of them or some component of them are net negative. But finding the kind of balance between how much insult you actually want to induce to produce an adaptation down the line versus how much is too much is a really, really tricky thing. So I want you to kind of describe that a little bit further within the confines of exercise-induced muscle damage, in terms of from a coaching perspective, some of it we actually want to produce an adaptation. And I'm wondering if we can kind of elaborate on that a little bit more before we get into all these mitigating things that we're going to discuss.
Yeah, sure. I mean, as you described it, there is exactly the way I would think about it. Is how much of that stress do you want to induce to stimulate adaptation. It's an old principle, a principle of hormesis, which is basically that you have a dose of stress up to a point which is beneficial, and then once you go over that limit, it starts to become negative. But defining where that limit is extremely difficult. My instinct is that for the majority of cases, as it relates to exercise and training, there are a few cases where we're inducing, especially in an exercise-induced muscle damage context, where we're inducing such a stress that we have to do something to intervene to make it better. Maybe in a competition scenario, where it could be, let's say it could be a 100-miler or something real difficult that might take a week or more to even recover from. There we might see an opportunity to intervene. But with training, it all comes back to, I use a performance priorities framework. So I work backwards from what are the determinants of success for this sport? What do we know about maximizing those determinants of success? What are the limitations to us actually implementing that strategy? So this is where we want to be. How do we develop those characteristics? Now, if you think about that from a training and a stress response, it's, well, we want to maximize training volume. We want to maximize stress to the point where the athlete can recover and get the maximal adaptation. So in my mind, I'm then looking at everything and thinking, well, what is it that I actually want to get rid of here? Is any of this negative? Is any of this actually going to impair the training response? So from a I suppose the type of soreness that you might get from a training stimulus, probably not. Firstly, the soreness itself, we don't really know exactly what the cause of that might be. But as it relates to things like inflammation and oxidative stress, I feel like there's been this sort of bandwagoning where the terms themselves have been sort of demonized. Yeah. And then without any real sort of scientific rigor, people have gone after it saying, right, let's find a nutritional solution or a physical solution to dampen this down. And there are a few points that are problematic with that. I think from an inflammatory perspective, if we think of inflammatory cytokines, some of the experimental research that's been done basically shows that if we, in a normal scenario, dampen those cytokines, we actually get an impaired adaptive response. We actually get impaired recovery. So that tells me that these things are absolutely necessary for normal recovery. The second point on that is when you look at repeated bouts of, let's say, eccentric exercise or downhill running, if inflammation was bad, you might expect that the body would dampen the response the more it gets adapted to the training stimulus. When actually what happens is you get a more sensitized immune response. So again, that tells me that there's a priority for the body to have a good immune response to this type of exercise. So I don't think interfering with it under normal circumstances makes any sense. And then with the oxidative stress side of things, there are several problems with this idea. The main one being that it's probably unlikely with any nutritional intervention that we can get the right thing in the right place at the right time to actually interfere with our body's own antioxidant system to deal with the normal oxidative stress response that we get. And even if we could, we might not want to do that because reactive oxygen species themselves stimulate adaptation. So I think the thinking around these things is maybe a little bit backwards sometimes. And again, maybe that's because the likes of you and I work in the real world. We see that, well, what we're trying to do is make people better. We're trying to stimulate adaptation. We're not trying to get rid of the signal. But unfortunately, that doesn't always come across in the research papers.
I was that point of we need to be supremely interested in the adaptive response was really drilled home to me kind of in my early coaching days by some of my very influential mentors that I had. And it's through that I kind of evaluate the literature, where I can like see things that come across the wire and appreciate the fact that, yes, we can reduce this inflammatory cytokine, we can reduce this sort of marker over here, but how does that actually impact the adaptive response? And Dan, you've been in the game enough for a long enough period of time, and I've been in the game enough for a long enough period of time. I'll put like a very practical lens on this. There was a period of time in maybe the 80s or even 90s where high antioxidant supplementation routines were very, very common in endurance athletes, because we thought that we wanted to quelch some sort of oxidative stress to whatever ends that we could, in order to help the athlete recover or help them improve. We now know, and it's actually quite clear, as you alluded to, that those types of supplement regimes, whether they're high vitamin C or vitamin E or whatever else it is, actually dampen the adaptive response. So it's been one of those things where if you look at it through the right vantage point, you're going to come to it with a much different conclusion. And your point of is, we tend to oversimplify this notion of, we want to stop everything that's bad and we want to perpetuate everything that's good. It's not quite that simple, because you have to have both of those in concert with each other in order to facilitate adaptation.
Yeah, absolutely. I couldn't agree more with that. I think it's worth reminding everyone that, the adaptation comes after the training stimulus. And that's always where we see all of these markers being elevated as well. So it's all good maximizing what we can do with an individual training session. What's the purpose of this session? Okay, we want to achieve X, Y, or Z. But all that adaptation occurs afterwards, and that's when all these things are elevated. All these markers that we think, are could be bad. So yeah, I think it's necessarily, and at sometimes science will be very reductionist and bring things down to very, very, very simple mechanisms. But we have to think much bigger than that, and beyond that as well. It's a balance, and I'd like to think we're very aware of that, because we do very basic mechanistic research, but we also try and take that to a very applied situation as well, so that we can really evaluate whether something is worth doing, but also if it's effective and practical as well.
That's a perfect backdrop, because I've picked out 2 supplements that could influence exercise muscle damage that we're going to talk about for the remainder of this podcast. But I think in the background, as you go through, because you're the expert here, the kind of the what the mechanisms are and what maybe the use cases are for using these supplements, I think in the background also we need to keep in mind and bring to light, and this is my reminder for me and my reminder for you, under what context could this actually make a positive difference? We understand kind of the physiological underpinnings behind how a couple of these supplements might actually work, but then we need to always keep in mind, as you do from a practitioner standpoint, when are we going to actually deploy them to facilitate adaptation, or to facilitate something that we actually want to get out of the athlete. Sure. So the first one to go over, and I picked 2 just because they're in the popular literature, just because it's fun. People ask me about it, really. I mean, I don't know if you have that same experience where you are, but for whatever reason, these 2, not every other day goes by where I have to answer something about this. So the first one are omega-3s, which has kind of continued to come up in the literature. It's another thing that got the spotlight put on it after the COVID pandemic. And the use cases for omega-3 in sports keep seeming to propagate, right? For everything from brain health to performance to anti-inflammatory properties and things like that. We're going to try to stick within the exercise-induced muscle damage side of things, just to give it a little bit of a tight time frame. But I want to mention those aspects, because I know that some of that context is actually out there. So first off, let's just set the table for what these are, and then within the sphere of exercise-induced muscle damage, what the theory or the mechanistic plausibility of those affecting that kind of pathway actually are.
Yeah, so with the omega-3s, they're essentially fatty acids. The ones that you would potentially take as a supplementation in a supplement form would be EPA and DHA. Usually with more EPA than DHA, and that's what's been studied quite a lot. From a muscle damage perspective, you're right. The thinking behind why these fatty acids might be useful is that they might have some mediating effect on inflammation, but maybe also on oxidative stress as well. So again, it's coming from this angle that potentially the increase in inflammation or oxidative stress is a bad thing, and therefore, if we provide these exogenous fish oils, as it were, that's where they come from, then we might have some beneficial effect. What I would say about it, first of all, is that it's important that beyond supplementation, there needs to be an appropriate dietary intake of these things anyway. So you need to have people at a good baseline of intake before you assess any of the efficacy around these things. Now, in some cases, some studies will eliminate intake from the diet in order to assess the utilization of these things in isolation. That can be said for like most things that get studied, whether it's polyphenols or whatever else it might be. But it's just important to say that first. The literature on this, I would say, is quite mixed. In some regards, some of the papers have shown that it can mitigate some of the soreness that's been associated with exercise-induced muscle damage. And other papers show that it potentially could reduce markers of inflammation or oxidative stress. Firstly, you could argue, again, is there a point in trying to do that? But the second and probably the most important one for me is if we're focusing specifically on muscle, there's only really one paper I'm aware of that has assessed whether taking on omega-3 fatty acids can actually increase the omega-3 fatty acid composition of the muscle. So that was done by a former LJMU graduate, Chris McGlory, who's now based out in Canada. And they basically looked at, again, if you give someone a high dose of omega-3 fatty acids for a long enough period, can it increase the amount of this in the muscle and therefore potentially have a meaningful effect? Now, they found that you needed around 5 grams a day in order to achieve that. If anyone goes away and has a look how much 5 grams a day of omega-3 fatty acids is going to cost you to achieve that, the cost-benefit ratio is way out of proportion. It's very expensive to get 5 grams a day of these things to perhaps increase the amount of these that accumulate in your muscle to a meaningful extent. So while they're undoubtedly important for normal biological function, so we need to get them in the diet, whether or not they're actually useful for the athlete is, I guess, open to question. The only time where practically I've used them to any degree is when I've had an athlete who's undergone quite a big insult, like a surgery, for example. So when I worked in contact sports, like rugby, we would have at least 1 or 2 players who would have a fairly difficult injury and perhaps a surgery per year. So we'd use that as a sort of support package around the surgery to try and mediate any excessive inflammation. But in the context of what we're talking about, I personally don't prescribe that to any of the athletes I would work with unless their dietary intake is quite low.
I'm glad you mentioned the dietary intake piece of it, and you also kind of coupled it with what some of how the research actually sets it up, where sometimes they'll actually remove that from the diet in order to see the effect of the actual intervention. Because something that I have noticed whenever I see a lot of this research come through the pipeline, and I want to get your perspective on this as well, is that let me see if I can stylize all of the findings correctly off the top of my head here. The improvements in whatever they're looking at are most pronounced whenever the subject group comes in with a deficiency in this area in the first place, and then therefore they're supplementing with this particular substance. it's not what you had mentioned on the latter part of it, where there's some super physiological level of the supplement actually of the supplement omega-3s actually taken in, where we actually see that. That's actually quite rare. And I've always viewed that as curious from a research standpoint. It's like, well, is it the diet that was deficient from the get-go that you're now all of a sudden making better just through a simple supplement? Or is it the supplement itself that's actually making a difference? And I'm wondering if you can provide any additional kind of like commentary on that from what you've observed.
Yeah, I think this is a general problem across this entire area of research. So I'm not that convinced that there's a really strong effect for these things as it relates to some of the muscle damage markers that we've been talking about. The only instance, as I say, where I think there was some interesting findings was in the scenario of, as I say, injury and disuse, because in some of that research, what they were able to show is that the loss of muscle mass following surgery was less in the group that had the high dose of fish oils given to them every day. So it could offer sort of some protective effect against the loss of muscle mass in that very unique scenario. But again, even that is still open to debate, and the authors of the papers themselves would say the exact same thing. Whether or not you should spend a lot of your money trying to get a really high dose of fish oils in is questionable right now. But as I say, the only scenario where I think there seems to be a benefit is if you've got an acute situation where you've got a planned surgery or so on. You could use a month before it to try and increase the amount of omega-3s that accumulate in the muscle to try and help prevent the amount of muscle mass loss that you get afterwards. But outside of that, whether or not they have a benefit on top of a well-rounded, well-balanced diet is open to question. And I think to make a comparison, we saw that a lot with some of the nitrates research,
Right.
whereby in athletes who have a lower, let's say a VO2 max below 65 mils per kilo per minute, there seemed to be a benefit, a more pronounced benefit. But in most of those studies, they remove dietary nitrate intake and then provide a very concentrated amount of nitrates, like beetroot juice, for example, or like a nitrate shot. So for most of those papers, you could ask the question, would these benefits persist on a diet that was rich in nitrates already? And I don't think there is a clear-cut answer to that, like many of the things that we're discussing here. If you can get most of them through the diet, do you get an extra benefit from having more of them? I think that's open to question.
Yeah, I think a takeaway for a lot of the listeners that are interested in this type of stuff is one of the keys that you can use when you're evaluating some of the literature that comes across the pipeline is to look at the baseline status of the subjects that are in the study itself. And did they actually do, if we're talking about nutritional intervention, did they actually do some sort of nutritional control going into it? And is that a realistic control in the real world? There might be reasons to do that from an experimental standpoint, but we don't live in an experiment. We live in the real world. And we always have to keep that in mind. It's the same thing for training interventions, right? If for whatever reason there's sometimes in a training intervention study, they'll do like a washout period where they won't have the subject train for 4 to 6 weeks going into a particular intervention. And then they'll do a training intervention and try to see the kind of the effect of that. You have to tease out what's going on mechanistically from this fictitious scenario that has been created in advance for whatever purposes. And for whatever reason on the nutrition side of things, it's just a harder, I think from a lot of people's perspective, it's a harder thing to actually tease out, to look at what the baseline of people are going into the study itself.
Oh, absolutely. Yeah. Well, I mean, we were examining a PhD the other day, myself and a colleague, and one of the discussions that we got into in that was around the fact that so few studies actually report what the baseline, for example, micronutrient status is of the participants, but then make conclusions about things that could very well be influenced by baseline micronutrient status. So even in the studies where they control some of these things, the lack of reporting of the detail that you really need to make conclusions is quite scary. So yeah, and honestly, for the listeners who might not be sort of involved in sort of research, the time that we spend sitting and talking about how we're going to design this experiment to, on the one hand, give us control, but on the other hand, give us some ecological validity, is probably where the most time is spent, because getting the balance right is really difficult and time consuming. So we do our best, and we're trying to get better and better and better at this, but it's very difficult to achieve.
Yeah, there's no perfect study. I don't envy the people in your position where you have to design those, because somebody is always going to point out the compromise that you inevitably made trying to balance those two elements, and that is always going to exist. I mean, that's just part of the nature of doing, especially experimental design types of studies. You can't get around that conflict. So once again, I'm appreciative of it, but I would also encourage the listeners, read more than the abstract and the conclusion, so you can get to this stuff. Okay, let's not bemoan that point anymore. I think we've hammered it home, Dan. The next thing I want to talk about is another supplement that has gotten a tremendous amount of press over the past really 3 years, and that's vitamin D. And the claims on this go from it's going to improve your VO2 max to it's going to improve your recovery, and on and on and on and on and on. We're going to talk about it specifically in an exercise-induced muscle damage standpoint, and try to stay out of the fray a little bit. But before we actually start out, why is vitamin D just important for athletes in general? Like, let's start with that big broad umbrella, and then we can kind of drill it down to the level of the muscle, this is your research, man. This is your wheelhouse that a tremendous amount about. So start out with the big picture.
Yeah, absolutely. So, I mean, I think the most important thing for people to remember is that we have a biological requirement for vitamin D, like we do other vitamins. So if you don't get enough of it, and we can talk about where it comes from, but if you don't get enough of it, you're going to start to see problems, and you'll end up with diseases. So it's not, I would encourage people not to think about it like maybe like an ergogenic aid, where we're using this to improve an aspect of performance or physiology. But without this, you have problems. So the interest in this for us came around due to the fact that we observed in a lot of elite athletes, and this is going 10, 12 years back now, that we saw the characteristic thing that we saw in the population, which is that from summer to winter, we're seeing this big decline in the amount of circulating vitamin D. And the overarching reason for this is that the main place we're going to get vitamin D from is exposure to sunlight. We produce 80 to 90% of our vitamin D from being exposed to UVB radiation. And we get a relatively small or insignificant contribution from the diet. We can get some from oily fish, we can get some from dairy products as well, but it's a small amount compared to what we produce from the sun. From a general health perspective, the main role of it is to regulate how we get the calcium from our diet into our blood. And that is essentially why when you have a severe vitamin D deficiency, the problems you typically see are related to bone. So for children, that looks like rickets. In adults, that looks like osteomalacia. And it's just a poor bone mineral density. Therefore, you have an increased fracture risk and so on. So the key function of it is to regulate calcium balance in the body. We also know, though, that pretty much every other cell in the body, not just bone, not just intestine and so on, every other cell, including muscle, seems to have the machinery to use vitamin D. So it tells us that there could be a requirement for many, many cells to use it, including the immune system, including muscle, just to name a few. So from a general health perspective, the key thing is that what we're trying to do with vitamin D is maintain a level that is considered to be adequate or sufficient and avoid deficiency. That is the main target goal. It's not to take us into some sort of super physiological range. That actually could be detrimental.
That is really important, by the way.
Yeah,
Like I don't like to interrupt my guests, but when they make a really important point, it's worth re-emphasizing that the goal with this is to avoid deficiency and not create a super physiological level of it.
Absolutely. I'd say that's the most important thing that anyone could take home from this particular segment, because from my time working with athletes, one of the problems that you see is that if something is good, then there's a belief that more of it's better, right? So this is good, I'm going to take 10 times the amount, and that's going to be even better.
Endurance athletes are the worst at that.
Yeah. Like, yeah, well, if I run this much and I could run 10 times more, then I'm going to, it's like, it's the whole thing. But yeah, with vitamin D, I mean, it's important also to know that without going into too much of the finer detail, it's not the same as other vitamins. The other vitamins, typically, if we have too much of them, for the most part, we can excrete them. We'll usually just pee them out. But vitamin D is actually structurally very similar to a steroid hormone. So it's not very much like a vitamin at all. And if we have too much of it for too long a period of time, we can get the opposite effect to what we intended to do in the first place. We start to pull some calcium out of the bone when we don't need to. And we just end up going in the opposite direction. So there's a real point here that when we say these are the recommended intakes, which we can get to, that's the recommended intake. We don't really need to be going tenfold above that, or trying to do anything special. We're just trying to get ourselves in the region of sufficiency all year round. That's our goal with it. So yeah, I mean, we can touch on how it's implicated in muscle damage, and then get to some of the practical considerations if you want.
Yeah, let's kind of level set the recommended intake first, and give maybe we can give a realistic food perspective on that. And the reason I want to do this is I kind of want to harp on this, like avoiding deficiency is the thing that we want to that is the primary takeaway with vitamin D, because there are a lot of supplement manufacturers that are taking advantage of the fact that this is a popular topic right now, and they're either enhancing or augmenting their blended supplements with more vitamin D in order to make the supplement seem more attractive or efficacious or valuable in the eyes of the consumer, because it's been in the literature so much. So it's been in the popular literature so much. So I think we could take just a little bit of time and just level set what are the recommended intake levels of it, and then how that couples with how you get it naturally just through sunlight first, and then we can go into how it might play a role in muscle damage.
Yeah, sure. So one of the things to preface this with is that depending on where you are in the world, your national health organization might have a different recommendation. And to make matters worse, there are some societies, like Society for Endocrinology, for example, they have their own suggestion as well.
I hate to make you try to put all of these together, because I know it's a big ball of wax.
Yeah, no, we can make it pretty simple, to be honest. I think I always come back to, first of all, what are the intakes that we need to achieve in most of the population the levels of vitamin D that are thought to be normal, and you prevent things like reductions in your immune system, in the recovery from muscle damage, for example. Whatever it might be. We just want to avoid anything that's associated with having lower intakes of vitamin D. So the normal blood levels that we'd look to try and get is above 50 nanomoles per liter. I'm aware that around the world that can be a little bit different. So for in the US, you might get that in nanograms per mil, and the conversion factor is about 2.5 times. So you go from let's say around 30 nanograms per mil will be about 75 nanomoles per liter, to put it in perspective. So we're looking to achieve at least above 50. But most people would probably agree now that around 75 nanomoles per liter is generally accepted as being the sort of target. Going above that, you don't really need to. I see a lot of athletes who come in with levels above 100 nanomoles per liter, and it's not a problem. But I think once you start to get upwards towards 200 and above, we tend to go, okay, why is it this high? Are you taking really high amounts of vitamin D, or what's going on here? In terms of the intakes to achieve that, I'll say this in international units, and because it works for the entire world, and that's what the publications are mostly in. But if you want to stick to conversion factor, like in the show notes or something, it might be helpful for people. But you can achieve those levels with around 1,000 to 2,000 international units per day, which I think is about 30 micrograms or so. I can't remember exactly the conversion factor, but 1,000 to 2,000 international units per day in the absence of significant sunlight exposure in the summer is enough. Now, in the past, we've studied up to 10,000 international units per day, and you don't need to do that. We actually see that you just start to break a lot of that down, so it's really not necessary. So my advice is during the winter months, 1,000 to 2,000 international units per day, and still trying to get amount from some oily fish in the diet if you eat fish, and the same, getting some dairy in there as well if again you can and you want to eat dairy. That's going to give you good levels throughout the winter. My advice in the summer is to try and seek safe sun exposure, which is always a bit of a touchy one because there are so many messages about avoiding the sun because of the risk of skin cancer. I'll say up front, there is absolutely a risk of skin cancer if you burn your skin. So I'm definitely not telling people to go and be trying to get as much sun as possible. But you only need about 15 to 30 minutes per day. You can have a t-shirt and shorts on, so it's only like half of your arms, half of your legs, and you really want to avoid burning the skin. That's enough to get you enough vitamin D through the summer. So even if it's like the first 15 minutes or so of being outside, and then you put your sunscreen on, that's absolutely fine. But you need that around three times a week or so. So during the summer, that's great. That'll probably take you, a little bit into winter. You'll have enough vitamin D, but then I like to start supplementation early in the winter to carry us through then into sort of springtime again. So it's a combination of, I suppose, behavioral changes of getting safe sun exposure, and then in the winter using a supplementation approach. And it really doesn't have to be aggressive. As I say, like 1,000 to 2,000 international units a day is going to get you where you need to be for the most part.
Dan, if you don't mind, I'm going to link up in the show notes a flow chart that I'm going to steal from Asker Jukendroop's website that is based off of a paper that you wrote, or primarily based off of a paper that you wrote in 2018. I'll leave the link to that article if somebody wants the nickel version, as well as the article that you wrote that kind of provides the platform for this vitamin D supplementation guide in the show notes. And for those of you listeners, the paper is vitamin D and the athlete, current perspectives and new challenges, which is in sports medicine in 2018. But if you just want to take a look at this infographic, it actually describes visually a lot of what you are going through, this kind of like if-then proposition of, if your blood level's this, and if you have sun exposure that, should you consider vitamin D supplementation? And I think the point that you're trying to make is first off, it doesn't take much sun exposure to get it. It doesn't take much vitamin D in the diet to get it. And then even if you are deficient, it doesn't take much supplementation to kind of get out of an area of deficiency.
Yeah, exactly. So there's you don't really need a big panic around this. It's just, it's simple changes that can actually make a fairly big difference, for sure. I mean, one thing I've over the past couple of years that I've really tried to think about with some of the vitamin D work though is like what are the practical solutions for people, because not everyone's going to have access to get bloods done, and even if you can, it's expensive, and even when you do, there are a lot of complications. Some of the assays that they use are not very good, and so on, and interpreting it becomes a bit of a mess. So honestly, I think the safest approach is what we just talked about. You don't need to go and get your blood tested. We know that if during the winter you're not going to see much sun exposure, you're not going to go to a sunny, a warmer climate nearer the equator. If you're wearing long clothes and garments, if you live or train or work indoors for most of the day, these are all risk factors that are going to reduce your vitamin D production. So if that sounds like your lifestyle, then you probably in the winter just need to take a small supplement to prevent it. And in the sun, just enjoy getting outside a little bit and just don't burn your skin. I mean, that's about this, the simplicity of it, really. Maybe with an elite athlete cohort, if I've got situations where we think, well, we've got the budget to test, then we will, because we'll really try and dial it in. And if we're seeing things that could be attributable to a vitamin D deficiency, then we might start to go, okay, we want to investigate this. But over time, I've really just come full circle, really, to try and have a much more simple perspective on it. And what I would say about that flow chart that you've shared, that there's a section of it that talks about free or bioavailable vitamin D, and I would just say to people, just ignore it now, because we're not convinced that it's a great approach to take anyway. So just take the easy one.
Yeah, there you go. Perfect. Okay. So now we're going to tie this back to exercise-induced muscle damage, because it's been postulated that adequate or even supplementation with vitamin D can somehow mitigate muscle damage or facilitate the repair. I'm going to put them into two kind of like different buckets, because those are two different things. So what is the origin of this? As my old mentor, JT Kearney, would say, go find the origin of that arrow first before you come and talk to me. What is the origin story of this? And then what does the research actually say in terms of could vitamin D supplementation or avoiding deficiency, I'm going to keep bringing that up, be effective on either one of those sides of the silo?
Yeah, so this all started, this was what my PhD was around, and we were interested in whether there was a role for vitamin D in skeletal muscle function. That was the original idea, because my mentors, Graham Close and James Morton, who were working heavily with athletes at the time, they'd seen this trend of athletes having low vitamin D levels in the winter. And we were like, well, is there any functional consequence of this? So my work was all around this. So we thought, okay, well, what's going to directly impact performance? It's muscle. So let's focus in on muscle as one area. And there'd been some data published that suggested that some of the components of muscle involved in muscle repair were responsive to vitamin D. So its ability to repair itself, some of the immune aspects of it as well, could be affected by whether or not you have enough vitamin D. So I set off to try and sort of figure this out. Split my PhD up into just muscle function, and then looking at the repair from a bout of damaging exercise. So does it protect from exercise-induced muscle damage? I would say we don't have any clue, and I don't see why it would. From a repair perspective, some of my work showed that if you are deficient, then you probably are going to have a poorer recovery rate after that bout of muscle damage compared to individuals who have higher vitamin D levels. So we experimentally controlled that by getting people in the winter who all had low vitamin D. We give one group a placebo, we gave one a vitamin D3 supplement, relatively modest dose. I think it was about 4,000 international units at the time. So we got one group back into a level of sufficiency. We kept one group low, and then we got them to do muscle damaging exercise before and after this supplementation period. And what we saw was that, in the supplementation group, they had a better rate of recovery following that bout of muscle damage than the placebo counterparts. We tried to do a bit of mechanistic work to support it. So we took some muscle biopsies from those people. We grew their muscle cells in little dishes in the lab. We treated them with vitamin D or nothing, and we damaged them. And then we looked at some of the sort of mechanisms that might underpin muscle repair. And we saw some improvements in aspects of, some of the markers that you would associate at the cellular level with muscle repair. So that simply said to me that, it's a very easy thing to do is avoid vitamin D deficiency. And if it can have an effect on the rate at which we recover from a moderate muscle damaging bout of exercise, then it's something that's really easy to solve. So that was kind of where we left it, to be honest. We didn't pick up much more work after that. There's been a lot more studies on muscle since, but as it relates to muscle damage, that was kind of as far as we took it.
And the storyline that keeps coming up is the avoiding deficiency piece of it, right? And I want to kind of pivot a little bit to some aspects of nutritional interventions that you can use that might not be a nothing burger, because that's what we've kind of got to, right? We've got omega-3s. Okay, if you're not deficient in it, then supplementing it isn't going to make a difference. Vitamin D, same thing. If you're not deficient in it, then supplementing is not going to be an issue. But I'm going to turn it over to you to maybe we can have it's not a positive, but maybe some like an actual directional arrow to like take away for the athletes. And you've looked at this from any number of perspectives. Are there any supplementation regimens or supplements themselves that actually do show promise to either prevent exercise-induced muscle damage or facilitate the repair after after an exercise bout that induces that muscle damage?
Yeah. So I think if we separate them out and say, is there anything we can do before? In my mind, the only things to be done before are to ensure that you've got adequate energy intake and a good distribution of macronutrients. So that's going to be what we do before, and we expose the muscle to some muscle damaging exercise before whatever the competition is. So from a nutritional perspective beforehand, not really. The only thing I would say is that vitamin D is that, like, we want to avoid a deficiency at any point in the year. When it comes to the repair process, again, there are very few things that have shown what I would think of as really meaningful changes in repair. So people have looked at things that might have an effect, like amino acids from protein. They've shown that supplemental protein doesn't do much as long as you've got enough amino acids available from the diet, then you'll be okay. And the other things that we talked about mostly have shown promise in mitigating the soreness. So things like tart cherries and pomegranate juice that are rich in polyphenols. There's some, I'd say, moderately good research that says, you can maybe mitigate the soreness associated with the exercise. So perhaps using some of those sort of functional foods could be a nice way to mitigate soreness. And I think there's relatively little risk with those things as well, because if anything, you're going to provide some additional nutrients in the diet. And I don't think the narrative that they might blunt the adaptive response is strong enough to say that it's not worth doing. So perhaps something like tart cherries or pomegranate juice, things like this, might have a positive effect. and as I say, it's not really expensive. It's got relatively little risk. So it's kind of like, why not? Why not use it? We're currently studying some other supplementation. At the moment, we don't know if it's going to have an effect, so I'm not going to go to tell people to start using it. But the idea around it is for it to be an alternative to non-steroidal anti-inflammatory drug use, which is quite prevalent, as you'll know, especially in ultra endurance athletes.
Sadly, so it's quite prevalent.
Yeah, and so we've got a multinational survey that we're going to release probably in the next 4 to 6 months, which is trying to characterize use by ultra endurance athletes. So we'll get that out to your listeners as well, and hopefully get a real big response rate. But we're going to have that in a couple of different languages so that we can try and really capture use of NSAIDs in training and competition by ultra endurance athletes. But we know there are some downsides to that, especially with prolonged use, and it may also hamper the adaptive response. So we're studying a compound called palmityl ethanolamide. It's a mouthful, so we just call it PEA for the sake of it for this. But we're interested in studying it from its ability to potentially modulate pain, but also its ability not to interfere with the mechanisms that are in play following a bout of muscle damage. So we're not really trying to amplify the adaptive response, but we're trying to come up with a solution to something other than NSAIDs that can potentially be, not detrimental to the athlete, but it is safe and easy to use. The good thing about PEA is we produce it endogenously anyway. It's actually part of the sort of cannabinoid signaling pathway. So it's, in a way, it's got some crosstalk with cannabinoids, but it is permitted for use by athletes. It's, as far as we know, safe, and in clinical settings, it's shown some promise for the management of pain in more clinical scenarios. So we're going to try and investigate that. We've got a downhill running study up and running at the moment, so really excited about that. And we're going to be doing a lot of biopsies and a lot of different things to try and really see if it does anything. But you'll hear about that whether it's positive or negative, because we'll publish the findings whether they show something or not. So potentially something on the horizon, but I'm certainly not going to go and tell people to go and start buying it right now, because we don't know. We've got no idea yet. So
well, I'll tell you what, anything that we can do, we collectively, the whole ecosystem, the research side, the coaching side, even the information that race directors and things like that send out to move people away from NSAID use to something else or nothing. That's an option. Just stop using them. Is a good trend, because I don't need to mention to you, but the use rates for NSAIDs in ultra running and endurance sports in general are kind of terrifying, knowing that some of the complications that they present, particularly in competition, where the body is being stressed out to a much greater degree than it is from a training perspective. Anything that we can do to educate people on not using those in competition, I think is a very, very good step forward, whether it's an alternative or it's just, don't use them at all. I'm going to link up a review paper that we actually reviewed in our coaching group just yesterday, in fact. It's open access. It's in the BMJ. And the title of it says it all. It's What is Known About the Health Effects of NSAIDs Use in Marathon and Ultra Endurance Running, a scoping review. So it's more of a commentary piece. It's not a systematic review. It's definitely more of a commentary piece, but it's a pretty easy read for people. And if you're curious about the deleterious effects of using NSAIDs while you're training and or while you're racing, I think that this is a really good place to start, and also might give you some ammunition to dissuade your fellow friends and athletes and colleagues from potentially doing this as well. So I'll be looking forward to that research very much, Dan.
Yeah, awesome. No, really appreciate that. And yeah, if we can get it out to as many people as we can, even characterizing what's currently going on, I think we can then we're then better placed to figure out solutions to how we can have a positive effect and actually help people and change practice, because it is one of the areas that I've seen in recent years where I've felt like that is something that is ripe for the taking, that we need to have a positive effect on. There are very few innovations, I think, in sports nutrition over recent years, and what athletes are doing around training and competition. And I think that is an area where there can be some decent innovation if people are willing to put time, money, research into doing something about it. So hopefully you'll be hearing from us soon about it.
Awesome. Yeah, I will link whatever you need me to in the show notes, because I think that that's a worthy cause. This has been fascinating. I know sometimes we come away with what I call nothing burgers, but I do think that a lot of times course correction is necessary within the space. I mentioned that from the onset. We went through that on antioxidants a couple of decades ago, and we need to continue to do that because, ultimately at the end of the day, athletes are spending a lot of time training, and we want to make sure that they're healthy and that they adapt to that training at a very, very minimal level. And the more information that we can get on some of the things that can help facilitate that, the better. Dan, where can people get to know a little bit more about you and your work, and maybe what else is going to come out of your lab, perhaps with previous podcast guests that we've had on here, Jamie Pugh, that might be coming down the pipeline?
Yeah, so from a research standpoint, I have a profile on the John Moores University page, so that updates with all like the research that we're currently publishing. But you could actually reach out to me on Twitter. I can give you my Twitter handle or LinkedIn, or by email. From sort of practice side of things, whether it's like an athlete inquiry related to coaching or nutrition, then I have a separate sort of business email. So again, we can stick that in the show notes. In terms of stuff that's coming up at the moment, with Jamie, who I know has been on the podcast, we've got a couple of different things going on. Some of that research is related to heat stress and the gut, and potential ways that we can mitigate some of the responses that we see to exercising in the heat. So we're specifically looking at probiotics and trying to figure out what effect they might have on ameliorating some of these nasty effects that we see with, especially taking on high amounts of carbohydrate in a hot scenario. So we're really excited about that. And Jamie will probably be involved in some of this work that we're doing to try and characterize NSAID use as well, given he's firmly placed in the ultra running world himself, with a bit of coaching and stuff that he does there. So we're really placed in a nice environment to do this work. I've got fantastic colleagues who are experts in a number of different areas. So if anyone wants sort of, if it's from a research point of view and you want to collaborate, then we're always open to that. We love to do so. Likewise, from a practice perspective, if anyone wants to get in touch and have a chat, please do so. More than happy to give some of my time to that.
Well, y'all keep cranking out really good research and really good information as well, not just stuff that shows up on the academic side. So I'm appreciative of it, and also appreciative of your time here. Thank you for coming on the podcast and enlightening the listeners to all this stuff. And we hope to see more come out of your group out there, and in particular in the ultramarathon world.
Awesome. Thank you for your time. Cheers.
All right, folks, there you have it. There you go. Much thanks to Dan for coming on the podcast today. The show notes for this particular episode are going to be an absolute treasure trove of information. So if you want to dive deeper into this topic or into the tangentially related topics, go check out the show notes. I'm going to have a lot of links to some of the papers that Dan has written in this area that really provide a great landscape for exercise-induced muscle damage and how some of these nutrition strategies may or may not affect all of those underlying processes. I hope and I hope that the audience out there appreciates one of the sentiments that we kept coming back to, and that is, in most cases, we should be supplementing if and only if there is a deficiency. Sure, there are some cases where some sort of supraphysiological level of a substance would provide an ergogenic effect, but that is certainly not the case with omega-3s or vitamin D. And I hope that the listeners take all that to heart, particularly when you are bombarded with all these advertisements and sponsorships on other podcasts that promote many of these supplements. As always, I appreciate the heck out of all the listeners out there. If you want to support this podcast, the best way to do it is to subscribe to Research Essentials for Ultrarunning. This newsletter is going on its 12th month. It's been in existence for a whole year. And one of the papers that we review just happens to be with omega-3s in a downhill condition. It's a really fascinating paper, and we pick it apart for exactly what it is. And if you're a subscriber and you've already seen us review this paper, you will understand that the conclusions that the authors reached weren't quite really what we could tease out from the data itself. So I hope you guys go and check it out. It's a fascinating newsletter. It is my favorite product to put out every single month. A link in the show notes will be to that. And that is the best way you can support this podcast, which has always come to you advertisement and sponsorship free. That is a commitment that I made at the very beginning of starting this podcast. And that's something that I will continue to make so that we can talk about supplements just like this and not get anybody all upset. All right, folks, that is it for today. And as always, we will see you out on the trails.